All right, so we're going to start exponential and logarithmic functions. So the very first lesson, we're still sticking with graphs, and we're going to actually be looking at exponential graphs. So the exponential format is y equals a, b, and then b to the power of x. So a few things. A is generally your y-intercept. And then b, if b is greater than 1, it means our graph is increasing. Okay. And if b is a decimal between 0 and 1, it means it's decreasing. So b will always be positive. So you're not going to see a negative value in an exponential graph. And then we just have some other characteristics here. So there are no x-intercepts, and that's because the exponential graphs have what we call an asymptote. So an asymptote means if I drew a line along the x-axis, our graph approaches that line forever, but it's never going to cross that line. So that's what an asymptote is when we look at exponential graphs. And then you can see the first graph is increasing because it's going up from left to right, and the second graph is decreasing because it's going down from left to right. So the y-intercept is that a value. The end behavior can be from 2 to 1, okay, actually in both scenarios. The domain is any real number because it does extend forever, and you need to be careful because sometimes in our calculators, you might graph an exponential graph and it might look like it kind of cuts off close to the x-axis. But it does continue forever, just sometimes when it gets close to that asymptote, it doesn't show up on your calculator. And then the range is y is greater than 0. So when we look over here, here's our very first graph. So there are no x-intercepts because this graph never crosses the x-axis. The y-intercept is at 3, and then the end behavior is from quadrant 2 to 1. And then our asymptote is right here at 0, so where y equals 0. When you look at the domain, it does extend forever to the left and the right, so it would be any real number. And then when you look at the range, we can see it's going up forever, so we would just say y is greater than 0, where y is any real number. It's not going to equal 0 because it's never actually going to touch that x-axis. It's just getting really close forever, infinitely closer. Okay, and then my formatting's not great here. Where did that graph go? But if we look at our other graph, I think I can kind of roughly draw it out here. I'm not sure why it didn't show up. But hopefully you have your paper in front of you. Okay, so we can see again there's no x-intercepts because it is a curve that's approaching the x-axis infinitely. The y-intercept on this graph is 2, and then the end behavior is from quadrant 2 to 1. So again, we have that asymptote at the same place at y equals 0, just across the x-axis. So that's, usually we write asymptotes as equations. And then the domain is any real number. And the range is y is greater than 0. So if the whole idea of an asymptote confuses you, don't worry. We usually don't get questions about them. But I think they help explain the range, right? And we do need to know the range. So the reason, that explains why there's no equal sign there, right? Because it's the graph doesn't actually cross at that point. It's just greater than 0. It never crosses that x-axis. Okay, so here's another quick slide. Just using what we've already talked about, it asks if the graph is, what the y-intercept is, and if it's increasing or decreasing. So again, that a value, that's our y-intercept. So in this case, it's at 3. And then we can figure out if it's increasing if our b value is greater than 1. So this one is, the b value is greater than 1, so it's increasing. And then here our y-intercept is at 5. And then our b value is less than 1, so it's decreasing. And then over here, our y-intercept is at 4. And if you don't know what this number is, e, it's actually an irrational number, kind of similar to pi. So it should be on your calculator. So I'm just going to take this calculator out and see if we can see it. So on this calculator, if you go second and then the e, that's the irrational number for e. So it is greater than 1. So that means that we are still increasing in this case. All right, so next up, we're going to actually look at what is an exponential function. So an exponential function really means that if we were to look at our table, that we're increasing in multiples, right? So you're not adding or subtracting, we're actually like multiplying from one value to get to the next. So if we look at this first table over here, we can see our y values at 1, and then 2, and then 4, and then 8. So you can kind of see it's doubling every time. So that b value would represent the doubling. So in this case, my b value would be 2. So it is an exponential function. All right. If we look at the other table, and again, I apologize for the formatting, you can kind of see that the y value, it looks like it's just decreasing, all right, by a certain number. So it's decreasing by about 2s each time, so that's not a multiple, so it's not being doubled or tripled or anything like that, or even cut in half. It's a linear equation because it's decreasing by a certain value. So this is not exponential. And then if we look at actual equations, here we go. So again, I'm going to rewrite this out because of the awful formatting. So whenever your variable is an exponent, so the exponent is a variable, that's going to be an exponential function. So yes, it's exponential. And then over here, sometimes they like to trick us, but even though we have an exponent, it is the number 2, it's an actual number, the variable is the base, so that means it's not exponential because our exponent would have to be the variable. Okay, moving on to example 4. So it just says, why could none of the graphs, so none of these graphs actually represent the function f at x equals 5 times 4 to the exponent of x. So remember, 5 is your y-intercept. Right, so right away we know that this first graph is incorrect. And then we also know that the 4 means because it's greater than 1, it should be increasing. So we know this one's incorrect because it's decreasing. And then I guess I could write y-intercept is wrong. And then the last graph, you're like, oh, well, it's increasing and has the right y-intercept. But do you notice how it crosses the x-axis? So we can't have that. So because that's part of the characteristic, so it can't cross x-axis. So this one and this, because there should be an asymptote there, so this one is wrong as well. All right, so example 5, the value of a painting increases exponentially over time. Which of the models the value? So when you look at all these exponential graphs we've been working with today, right, they're a curved line. So right away I know that this can't be right and this can't be right. So really we're going to look at A and C. So the only difference is it kind of has, A is a y-intercept, so it starts at 0. C is a y-intercept, not at 0. So we're going to assume that the painting is going to be worth more than $0, right? Like no one has a painting they buy that is $0 to start with. It's probably worth something. So the answer that makes the most sense is C. So now we're going to solve graphically. Again, I'm going to rewrite this because unfortunately formatting is not great. So just like we've always done, when you have two sides of an equation, you put one side into y1 and one side into y2, and then we just find the intersection point. Doesn't matter which side is which, so I just put the left side of the equation 29 into y1 and the right side into y2. And then we'll go to graph. So remember, you do need to adjust your window. So if I have a line at 29, that means my y max has to be bigger than 29. So I'm going to make it 35. Here we go. We can clearly see the intersection point. So now I'm going to move my cursor close to that intersection point. I'll press enter, enter, enter. And then unfortunately it doesn't work great on my calculator, but hopefully it works on yours, and it should be at 2.09. But those are the steps you would go through. Okay, now we're going to try this one. Again, I'll rewrite it so it looks a little nicer. Okay, so we're going to go and type it in. Clear what I have here. So I got 4,200 into y1, and then y2 is 3 to the exponent of x over 4. So if I go to my window, my y max should be bigger than that 4,200, so I'm going to make it 4,500. So I'm like, okay, I don't really see anything. What if we try making the x max bigger? So I'm going to try making this 100 just to see. Oh, there we go. Now we can see an intersection point. And then we'll go second, trace, intersect. So when you don't see a graph, right, make sure you try playing around with the window. Don't just graph it and give up, right? Try different windows. So again, I'm going to try the intersection point. It doesn't work great on my calculator, but hopefully it works on yours. You should be getting 30.4. 30.4. All right, let's try a couple diploma questions before we pack her in. So here it just gives us an equation of a bacteria doubling, and it just says, what would the minutes have to be in order to at least equal 6,800? So I'm going to make this equal to 6,800, and then I'm going to solve for m. So again, this is just something we can do on our calculator. So let's go ahead and try typing it in. So I have 40, oh, wrong question. 6,800 to the exponent of x over 20 graph. Oh, let's adjust the window. So I feel like m represents minutes. So I have 100 minutes right now. Let's keep that. And then the y represents, it needs to at least be 6,800, so I'm going to make it 8,000. So it doesn't look like it's going to intersect anytime soon. So I might need more than 100 minutes. So I'm going to try 500 minutes. Oh, there we see the intersection point. So second, trace, intersect. I'll move my cursor close to the intersection point. Okay, and then if you type it in, you should get 254.62. So remember, this is one of those ones where you do need to pay attention to that at least. So if we round down, right, we wouldn't have enough bacteria, so we do need to round up to 255 minutes. Okay, last diploma question. So it just kind of gives you a little different one. So it says, here's my equation. Which graph would represent this equation? So right away, one of our lines, like, right, we always type 1 into y1 and 1 into y2. We should have a line at 3. So I know A is wrong and C is wrong because their line is at y equals 2, not 3. Now I need to figure out, is it B or D? So I'm looking at these and I'm like, well, what's the difference? So this ordered pair is the difference. So here, when x is 1, it has y is 10. And over here, it has when x is 1, y is 5. Okay, so if I type this in my calculator, and I replace x with 1, 2 times 5 to the exponent of 1 gives me 10. So I'm like, perfect, that works. If you try it over here, right? You don't get 5, obviously. So then the right answer would have to be B, because that actually works and gives me an ordered pair that it shows up on the graph. All right, try some of these workbook questions to get a little bit of practice in.